Okay, there's the note sheet that I said we're going to do first. Let me zoom in. There we go. Should be able to see that. 1.2 notes, properties of real numbers. Here is the properties for real numbers. We're going to use capital letters to represent the names of them. So R is going to represent real numbers, and everything today is a real number. Q is a rational number, I is irrational, and so on. So we're going to use the capital letters to label what our questions are. I need to zoom in a little bit more. There we go. All right. So, number one, 6,425. What categories of classifications of numbers does this fall into? Well, if you look at it, everything is an R. Okay? So everything is going to be an R. That's one. All of these are going to be an R. Okay? What else does it fall into? Well, can I make it a fraction? Could I write 6,425 as a fraction if I had to? Absolutely. So it's a Q. Okay. Is it an irrational number based on the notes? Is it a decimal that never ends? No, that's not a decimal, so it's not an I. Is it a natural number? Is it 1, 2, 3, 4, 5? Could I go all the way up and hit that number? Absolutely. So it's an N. Is it a whole number? Yes, it is. So it's a W. Okay. And is it an integer? Is it a positive or negative whole number? Yeah, it's a positive number, so it's an integer too. So this number, 6,425, fits into all these classifications, all those categories. Okay. Number 2, square root of 7. If you plug that into your calculator, it's a decimal that never ends, so it's just an R and an I. It's an irrational number. If you remember from your notes, if it's an I, it's all by itself. It's in its own category. You should recognize that symbol. That's pi. Pi is a decimal that never ends, so it's also an R and an I. 0, 0, again, everything is an R, so all these are R's, so 0. What does 0 fall into? Can I make 0 a fraction? Can I write it as a fraction? Yes, fractions. Okay, is it an irrational number? No, because that's its own category. Is it a natural number? No, natural numbers do not have 0, but it's a whole number and an integer. See the 0? It's a whole number and an integer, so it's a W and a Z. Oops, there we go. Okay. Number 5, this may look confusing, or you see the square root, so you're thinking it's going to be an irrational number, but the square root of 25 is 5, and the square root of 36 is 6. So this technically is just a fraction of 5/6, right? So it is an R, because all numbers are R today. And is it a fraction? Is it a fraction? Yes, it is. It's already a fraction, isn't it? So it's a Q. Remember, it's not an I. I's are kind of separate all by themselves. They're irrational numbers. They're in their own category. Okay. Is it a natural number? Look at these 3 less categories: natural number, whole numbers, and integers. Do you see any fractions or decimals? No. So 5 is just R and a Q. Okay. 6. It's up here. It's the square root of negative 16. Well, the square root of 16 is 4, so technically this is just negative 4. So that's the number we're dealing with, right? Okay, so negative 4, what does it fall into? Well, everything is an R. Okay. Can I make it a fraction? Can I make negative 4 a fraction? Sure I could. I can just put it over 1. There's a fraction. So it's a Q. Okay, and it's a Z. Okay, it's not a natural number or a whole number because those don't have negatives. Z has the negatives, right? So it's a Z, it's a negative 4, okay? Number 7. Again, Number 7 is a negative whole number, just like 16, so 6 and 7 are essentially the same category. They're just negative whole numbers, so they're both RQZ. Okay, this is a negative, but it's not a whole number, it's a decimal, right? So again, this is an R, everything is an R, okay? And can I make the decimal a fraction? Are fractions the same as decimals? Yes, they are. Okay. And then the rest of these, it's a decimal that does repeat. So this doesn't. It's not an I, because this would have to have a repeating decimal that never repeats and never ends. This ends. Okay. And then the rest of these don't have any decimals at all. So 8 is just an R and a Q. Okay. All right. Next ones. We got some properties down here. Now, this worksheet doesn't have all the properties that were on the PowerPoint. There's other ones on here, and we'll get to those when we see them. Okay, so the next one's down here. We have to name the property. So on number 9, if you look at this right here, so you got 5x and 5x, right? So you can think of this as like an A, and that's an A, right? And then you've got this and this is like a B, right? So you got A times B and A times B, but what's inside of B just kind of flip-flops, right? So you got to look at that and say, okay, which one of those does it fit into, right? Okay. So if you look at that, the property would be commutative property, and we can just abbreviate commutative property, right? Okay, 10, same thing. If you look at this, you've got 7x, right? So you've got an A, a B, a C, an A, a B, and a C. If you look, they're in the same order. A is 7x, it comes first. B is 9x, it comes second. A to C, it comes third. What do? They put parentheses around B, C over here, and they put parentheses around A, B there. So they just changed where the parentheses were, okay? So if you look up here in the directions, look what they did. They changed the parentheses. The parentheses around A and B, then it's around B and C. Okay, except this is addition. So it's addition, so it's associative property of addition. So associative property of addition. Okay. So 10 is associative property of addition. 11, if you look at this, what's on the left is exactly what's on the right. Okay, and you might think that that's distributive property, but it's not, because they didn't actually distribute. They didn't put 15x over here and 5y over here. What's on the left is the same as the right, and that's reflexive, which was in our notes. It was in the PowerPoint. It's not up here, but it was in the PowerPoint, so we still have to remember it. So this is reflexive. Okay, 12. Now this one, look at the difference on this one. This is the distributive property, because 7 times n is 7n. 7 times 2 is 2n. So this is the distributive property. Okay. 13. Okay, if you look at this, you've got a 3, 2xy, you got a 3, 2xy. The only thing they did was change where the parentheses go, and when you change where the parentheses go, that is associative property, just like here, they changed where the parentheses go. Okay, this is of multiplication. So I'm just going to put an X. So this is associative property of multiplication. 14, all right? So here you've got 3 times x times 2 times y. Well, does order matter when you multiply? No, this is still 3 times 2 times x times y. This is still 3 times 2 times x times y. Order doesn't matter when you multiply. So this is associative property. of multiplication. Okay. Let's do the back side. Okay, so we got 4 more properties up here. Okay, this one right here. What did they do? They took the 6 and the -6 and changed it to a 0, so they substituted these two for a 0, so this is substitution. Alright, 16. If you remember from the notes, whenever you multiply two numbers and you get 1, that's the multiplicative inverse property. So, two numbers and multiply get 1 is multiplicative inverse. Okay, 17. Look what we got here. They took 5 times x and got 5x, 5 times y and got 5y. That's the distributive property again. Okay, and on this one, what did they do? They added 0, didn't they? Okay, so when you add 0, that's just the additive identity property. Because you didn't change the identity. It started out as a 4n, you added 0, it stayed a 4n. So the identity of the 4n did not change, so it's the additive identity property. Alright? So here we go, we got the additive inverse. Well, multiplicative inverse is two numbers that multiply to get 1. The additive inverse are two numbers that add together to get 0. So what can I add to 0.4 to get to equal 0? Well, I can add what? I can add a negative 0.4. So a negative 0.4 gives me 0. Right? We also have to do the multiplicative inverse. We'll do that in a minute. Okay, so what do I have to add to this? So what do I have to add to this to get 0? I have to add a positive 1.6, just the opposite number. What do I have to add to this to get 0? A negative 5 and 5, 6. Okay, so positive and negative are the same number. That's the additive inverse. Okay, multiplicative inverse. Those are two numbers that multiply to get 1. All right. So, what can I multiply 0.4 to get 1? Right. Well, it might be easiest to turn these to fractions. Why do I say that? Because 1/4. All I have to do is flip the fraction to 4 over 1, and I get 1. So if I can make these fractions and just flip them, it's easier. So let's make this a fraction. All right. So I make that's 4/10. So technically I can write that as 4 over 10, right? So let's reduce that. So half of 4 is 2, half of 10 is 5. So I have 2/5 technically. So that's my reduced fraction. So now let's flip that, right? And so 5 over 2 is equal to 1. So the multiplicative inverse is 5 over 2. All right, so change them to fractions, reduce them, and then flip them. Okay, so let's change this to a fraction, flip it, and reduce it and then flip it. So number 20, okay, that's negative 1 and 1/6. So that's negative 1 and 6/10, right? So let's reduce this, or you can turn it into an improper fraction and get 1 times 10 is 10, plus 6 is 16 over 10, and then reduce it, but I could just reduce this and get negative 1 and 3/5. Okay, let's change that to a improper fraction. So 1 times 5 is 5, plus 3 is 8. So I have a negative 8 fifths, sorry. So I have a negative 8/5. So now this is reduced, so all we have to do is flip it. So the multiplicative inverse is going to be a negative 5 over 8. Now, it stays a negative because the multiplicative inverse has to equal 1, positive 1. So if it's negative, it stays negative. So I changed negative 1.6 to this, and then I just flipped it. So there's my answer. Okay. Okay, 21, same thing. We can change this. This is already reduced, so 5 times 6 is 30, plus 5 is 35/6. So I change it to a fraction, so now all I have to do is flip it. So the multiplicative inverse would be 6 over 35, because that equals 1. Okay? Change them to fractions and flip them. All right? And that'll be it for today. We'll do these later. We'll simplify these expressions later at another time.